Hey guys, today we are going to find some exact sine, cosine, and tangent values using sum and difference identities. So we'll start by reviewing some properties, our reciprocal properties. Sine and cosecant are reciprocals of each other. So sine x is 1 over cosecant x, and cosecant x is 1 over sine x. Cosine and secant are reciprocals. Cosine x is 1 over secant x. And secant x is 1 over cosine x. And tangent and cotangent are reciprocals of each other. Tangent x is 1 over cosine x, or cotangent x. And cotangent x is 1 over tangent x. And the quotient identities, tangent x is the same as sine x over cosine x. And cotangent is the reciprocal of tangent, so it is cosine x over sine x. We are not going to use the opposite angle identities. We'll go to the Pythagorean identity. Sine squared plus cosine squared is 1. Which means sine squared x is 1 minus cosine squared x. And cosine squared x is 1 minus sine squared x. So that's just a matter of moving cosine to the other side or moving sine to the other side and solving for the remaining one. Tangent squared x plus 1 is secant squared x. So if I solve for tangent squared x, I would get tangent squared x equals secant squared x minus 1. Or 1 equals secant squared x minus tangent squared x. And 1 plus cotangent squared x is cosecant squared x. Or if I solve for the 1, I would get 1 equals cosecant squared x minus cotangent squared x. Or cotangent squared x equals 1, or equals cosecant squared x minus 1. And now some new identities. Sum and difference identities. If I have a number that doesn't really fit, a number of degrees that doesn't really fit very well onto the unit circle, I can find two numbers that do fit onto the unit circle and add them together or subtract them. So if I'm doing sine of alpha plus beta or alpha minus beta, I can do sine alpha cosine beta plus or minus cosine alpha sine beta. Now that plus or minus, notice there's a plus or minus there and there. Whatever sign I use here, I use here. So use same sign. But notice here, with cosine, there's a plus or minus, but here it's minus or plus. That means use opposite sign. And in tangent, there's a plus or minus, use same sign, and a minus or plus, use opposite sign. So if I'm doing cosine, I'm doing cosine alpha, cosine beta, minus or plus sine alpha, sine beta. In tangent, alpha plus or minus beta is tangent alpha plus or minus tangent beta over 1 minus or plus tan alpha, tan beta. So we will try some problems, and that will probably help put this together, what it actually means. So sine 195, I want an exact value, but on my unit circle, I do not have a 195. But for example, if I add, say, 150 and 45, that makes 195. So this is the same as sine 150 plus 45. So that would make 150 my alpha and 45 my beta. Okay, so sine 150 plus 45 is sine alpha, so that's sine 150, times cosine beta, so that's cosine 45, plus or minus, there's a plus here, plus or minus, use same sign, so I'm going to use that plus. Cosine alpha, so cosine 150, sine beta, sine 45. So sine 150, sine is a y value, and it's the first position up, and that's 1 over 2. So sine 150 is 1/2. Cosine at 45, cosine is an x value, and that is the second position to the right, which is root 2 over 2. Then cosine at 150, the x value at 150, that's the third position to the left, which is negative root 3 over 2. And then sine 45, so we've already found cosine at 45, it's root 2 over 2. Sine is the y value, it is the second position up, which is root 2 over 2. Okay, so now we can simplify this. 1/2 times root 2 over 2 is root 2 over 4. Then we have plus, but when we multiply, it's negative times a positive, which is going to become a negative. Root 3 times root 2 is root 6 over 4. So that's my final answer. Or I could write it in one fraction as root 2 minus root 6 over 4. So that answer would be just fine as well. Or if I had these the other way around, I could have negative root 6 plus root 2 over 4. Cosine at 165. 165 is not on this unit circle, but we could use maybe 135 and 30. And this time we are going to use the cosine sum and difference identity, which is cosine alpha, cosine beta, minus or plus, meaning opposite sign, sine alpha, sine beta. So we're doing cosine 135 plus 30 to get our 165. So that's cosine alpha, cosine beta. So that's cosine 135 times cosine 30. Minus or plus means use opposite sign. I've got a plus here, so I've got a minus here. Then sine alpha, sine beta, sine 135, cosine, or sine 135. And I already did 135, sine 30. So I've got cosine alpha, cosine beta, minus sine alpha, sine beta. So cosine at 135, that is the x value. It's the second position left. So it is negative root 2 over 2. Cosine at 30, it's the third position to the right. Root 3 over 2. And minus sine at 135. The y value, it is the second position up. Root 2 over 2. Times sine at 30. The y value at 30. First position up, 1 over 2. So now I simplify. Negative root 2 times root 3 is negative root 6. 2 times 2 is 4. minus root 2 times 1, 2 times 2. Okay, and again, I can write that as negative root 6 minus root 2 all over 4. I can have that backwards, negative root 2 minus root 6 over 4. Okay, now these are not the only two numbers that I could possibly have used, but whatever numbers I used should simplify to an equivalent of this answer. Tangent. Now when we do tangent, it's going to get a little bit longer. So we want to try to make sure we are not writing too large. Okay, and this one happens to be in radians. Pi over 12. So we need to rewrite these as radians, and I think we can get away with just doing the top. So we've got 1/6 pi. And then I'm just going to do the sixths for now. 1/6, 2/6, which is 1/3. Might be easier if I keep it in sixths, since this is twelfths. So let's just do this all in twelfths instead. So 1/6 is 2/12. 2/6 is 4/12. 3/6 is 6/12. 4/6 is 8/12. 5/6 is 10/12. And 6/6 is 12/12. We need something that makes 1 pi over 12. Okay, so far I'm not seeing any way to do that, so let's go ahead and put in these fourths. This is 1/4, which is 3 pi over 12. Okay, so now I can actually see if I do 3 pi over 12 minus 2 pi over 12. 3 pi over 12 minus 2 pi over 12. That is 1 pi over 12. So I can use these two spots, but I really want to use their simplified form, which is pi over 4 and pi over 6. So this is the same as tangent pi over 4 minus pi over 6. So the tangent sum or difference identity is tan alpha plus or minus tan beta, which means use the same sign, over 1 minus or plus tan alpha tan beta. So I've got a minus, which means in the top I'm going to keep a minus, because it says plus or minus means keep the same sign. So it's tan alpha minus, plus or minus tan beta, so tan pi over 4 minus pi over 6, minus tangent pi over 6, all over 1, and then it's minus or plus, which means change the sign, so I'll change to a plus, tan alpha times tan beta, so tan pi over 4 times tan pi over 6. So tangent is y over x. So the y value at pi over 4, right here. Second position up, the y value is root 2 over 2. The x value, we're in the second position out, so it is also root 2 over 2. So for tangent pi over 4, I've got root 2 over 2, the y value, over root 2 over 2, the x value. Then tangent at pi over 6. The y value, first position up, is 1 over 2. The x value, third position to the right, is root 3 over 2. So y over x is 1/2 over root 3 over 2. And that's all over 1 plus tangent at pi over 4, which is this, times tangent at pi over 6, which is this, but when I rewrite it down here, I'm going to put the simplified form. So the tangent at pi over 4, root 2 over 2 over root 2 over 2. That cancels. That's 1. Then the simplified form here. If I do an outer loop, I'm going to get 2. And an inner loop, I'm going to get 2 root 3, which is 1 over root 3, simplifying those. And if I multiply top and bottom both by root 3, I'm going to get root 3 over 3. So I'm going to write this in a much more simplified form. So that's 1 minus, and I just simplified all of this to root 3 over 3, all over 1 plus 1 times root 3 over 3, which is root 3 over 3. Okay? So next, I need to be able to combine these terms in the numerator and then these in the denominator. 1, written with a common denominator here, is going to be 3/3. So it's 3/3 minus root 3 over 3 over 3/3 plus root 3 over 3. So now I can simplify that to 3 minus root 3 all over 3, and 3 plus root 3 all over 3. Okay? If I do an outer loop, I get 3 times 3 minus root 3, and I'm not going to distribute that, and you'll see why in a moment. And the inner loop gives me a denominator, 3 times 3 plus root 3. And that 3 over 3 cancels. So I have 3 minus root 3 over 3 plus root 3. By rule, we cannot leave that radical in the denominator, so we're going to do something that's called multiplying by the conjugate of the denominator. So I'm going to multiply top and bottom both by 3 minus root 3, because that's the same thing as the denominator, but with an opposite sign. So we are multiplying by conjugate of the denominator. So I get 9 minus 3 root 3 minus 3 root 3 is minus 6 root 3. And negative root 3 times negative root 3 is positive 3. And now we'll see why we multiplied by the conjugate of the denominator. 3 times 3 is 9. Then minus 3 root 3 plus 3 root 3, and those cancel each other out. And then the last term, negative root 3 times positive root 3 is negative 3. So we've got 9, sorry, I need to combine my like terms here. 9 plus 3 is 12, minus 6 root 3, and 9 minus 3 is 6. 6 goes into all three terms, 2 times, 1 time, and 1 time. So we've got 2 minus root 3 as our final answer. Our last one is secant at 465 degrees. It would be easiest to use the lowest positive coterminal angle, so 465 minus 360, and that is 105. So we are doing secant of 105 degrees. 105 does not show up on the unit circle. So there's multiple ways to make 105. I'm going to do 150 minus 45. So it's secant 150 degrees minus 45 degrees. It's not the only way to do it, but it's the way I'm choosing. Secant is reciprocal of cosine, so it's really 1 over cosine. 150 minus 45. So we're going to do 1 over the cosine sum or difference identity, which is cosine alpha, cosine beta. So that's cosine 150, cosine 45. And then it's minus or plus. I have a minus here, so I have a plus here. Sine alpha, sine beta. Sine 150, sine 45. So 1 over cosine 150, that's the x value. Third position left is root 3 over 2. Cosine 45, that's the second position right. Root 2 over 2. I have an error here because my cosine 150 is to the left. That should have been negative. Negative root 3 over 2 for cosine 150. 2 root 2 for sine 45, or for cosine 45. Then plus sine 150. It is up, so it's positive. First position, 1 over 2. Sine 45, it's up, so it's positive. Second position, root 2 over 2. So now we simplify. Negative root 3 over 2 times positive root 2 over 2 is negative root 6 over 4. And 1 over 2 times root 2 over 2 is root 2 over 4. So I can simplify to 1 over negative root 6 plus root 2 over 4. And then I can do loops. Now this 1 is the same as 1 over 1. So my outer loop is 4. That's the numerator. And my inner loop is negative root 6 plus root 2. And I can multiply now by the conjugate of the denominator, which is negative root 6 minus root 2. Okay, now the top, I'm just going to keep it as it is for now and see later if I want to leave it like this or distribute. If I can end up simplifying with that 4, I won't need to distribute. So first term, negative root 6 times negative root 6 is positive 6. Then I get positive root 12 and negative root 12, and those will cancel. So that's why I'm multiplying by the conjugate, to cancel those out. And then root 2 times negative root 2 is negative 2. So I've got 4 times negative root 6 minus root 2 all over 4. And those 4's cancel. Negative root 6 minus root 2.